Hello and welcome to the Unit 3, Section 4 video on function notation, and we'll also be talking about the graph of functions. So in the last section we talked about domain and range. We've also in this unit earlier have talked about whether or not something is a function. So now we're going to talk about notating it using an equation. So for an equation, we have this example, y equals 3x minus 8. And that's how it's read, y equals 3x minus 8. X represents the input, and y represents the output. Well, in function notation, we have f of x in place of y. Basically what we're saying is this is a function in terms of x. That's what f of x stands for. And we still have it equal to the same thing that we do over here. So it's read as f of x equals 3x minus 8. Again, x represents the input. F of x represents the output. So we put in a value of x, we get a result. So let's do some examples of this. We're going to find the range for the following function given the domain -1, 0, 1, and 2. So we'll do this by finding out what f of x is for each one of these. So f of -1 is 4 times -1 minus 2. So that gives us -4 minus 2, which gives us -6. F of 0 is 4 times 0 minus 2. So that just gives us -2. F of 1 is 4 times 1 minus 2, which would just be 2. And f of 2 is 4 times 2 minus 2, which would give us 6. So in each one of these cases, we're just plugging in our value of x from our domain to find what our value for our range would be. So the range of this would be -6, -2, 2, and 6. That would be our range. All right, we're going to find the range for this function. So again, it's just a matter of plugging in. So we have -3 squared minus 2 times -3 minus 6. Minus 6. Okay, so we know that -3 squared is 9. And then -2 times -3 is positive 6, and then got minus 6. So f of -3 is 9. F of -1, we're putting in -1 in place of x, so we got -1 squared minus 2 times -1 minus 6. So that's going to give us 1 plus 2 minus 6. And so we get -3. For f of 2, we're going to have 2 squared minus 2 times 2. So 2 squared minus 2 times 2 minus 6. That's 4 minus 4 minus 6, which gives us -6. And then 4 squared minus 2 times 4 minus 6. So that's going to be 16 minus 6 gives us 10, minus 8 gives us 2. And so our range of values would be 9, -3, -6, and 2. So now let's talk about the graph of a function. So we're going to graph each function for the domain. And we'll start with this first example. So our values for x are our domain values. So you've got -2, -1, 0, 1, and 2. We're short by a slot, but that's okay. So up here, we're going to put in this column, f of x, which in this case is negative 3x minus 5. So f of negative 2 is going to be negative 3 times negative 2 minus 5. And that's going to give us 6 minus 5, which is 1. Then we do negative 3 times negative 1 minus 5. That's going to give us 3 minus 5, which is negative 2. Then we have negative 3 times 0 minus 5, and that's going to give us negative 5. Then we have negative 3 times 1 minus 5, which is negative 8. And then finally, negative 3 times 2 minus 5, which gives us negative 11. So we're going to write down our sets of ordered pairs. We've got negative 2, 1, negative 1, negative 2, 0, negative 5, 1, negative 8, and 2, negative 11. And then we can just plot these. So we've got negative 2, 1, negative 1, negative 2, 0, 5, or 0, negative 5, I should say. And then we have 1, negative 8, and then 2, negative 11, which would put us somewhere around here. Now you notice these points make a straight line. If we were to connect them, we would have a straight line. What we have here is the graph of a line. We're going to be talking more about that as we go along, but this is a graph of a line. All right, let's do number 2. So for number 2, our x values are negative 2, negative 1, 0, 1, and 2. And our f of x is going to be, just like we wrote up here, we have f of x equals 4x minus 4. And so for negative 2, we're going to put that in for x. We get negative 8 minus 4, which gives us negative 12. Then 4 times negative 1, that's negative 4 minus 4 gives us negative 8. 4 times 0 is 0 minus 4 gives us negative 4. 4 times 1 is 4 minus 4 gives us 0. And then 4 times 2 is 8 minus 4 gives us 4. So again, we're going to have a set of ordered pairs. Negative 2, negative 12. Negative 1, negative 8. 0, negative 4. 1, 0. And 2, 4. And we can graph those. Negative 2, negative 12 is going to fall somewhere down here. Negative 1, negative 8 is going to be here. 0, negative 4 is here. 0, 1, 0 is here. And then 2, 4 is up here. And again, if you were to connect those dots, you would have a straight line. So again, we have the equation of a line. All right, for example 3, let's fill out the table one more time. Negative 2, negative 1, 0, 1, and 2. This time our function has a square in it. We have x squared minus 6x plus 2. So let's plug in negative 2. We've got negative 2 squared minus 6 times negative 2 plus 2. That's going to be 4 plus 12, which is 16, plus 2 gives us 18. So we won't be able to graph that one. We've got negative 1 squared minus 6 times negative 1 plus 2. So that's going to give us 1 plus 6, which is 7, plus 2 gives us 9. For 0, we have 0 squared minus 6 times 0 plus 2, which is going to give us 2. 1 squared minus 6 times 1 plus 2. That's going to be 1 minus 6, which is negative 5, plus 2, which gives us negative 3. And then finally 2 squared plus minus 6 times 2 plus 2. That's going to be 4 minus 12, which gives us negative 8, plus 2 gives us negative 6. So our ordered pairs are negative 2, 18, negative 1, 9, 0, 2, 1, negative 3, and 2, negative 6. So we can't graph the first point, but we'll start with the second one. We have 1, 9. We have 0, 2. We have 1, negative 3. And we have 2, negative 6. Now, you'll notice that this doesn't form a straight line. It's going to form more of a curve. And we're going to be talking about that. The specific type of curve it's called is called a parabola. And we'll be getting more into that later on in the course. But for now, just keep that in the back of your mind, the term parabola. You get that with x squared functions. All right, let's do something that's a little bit easier and a little less work. Given the graph of the function f of x, we are going to find these things. So here we are given the graph. And we are going to find out what f of negative 4 is. Well, negative 4 is our x, so we're just going to go back to negative 4 on the x-axis. And then we're going to follow it to our function and read off our y. So f of negative 4 is 2. F of 0 is 0 because the function's right there. F of 3, if we go to 3 and we come back down, we've got about negative 1.9. You can estimate it. F of negative 5, well, that would be 0. Now, what is x when f of x equals 2? Now we're going to look at the y value. What is x when f of x is 2? Well, it's two things. It could be either negative 4, or it could be negative 0.9. Let's say negative 0.9. So we could say it's going to be either 2 or actually no, not 2, negative 4. That's the x value, negative 4 or negative 0.9. Now, what about when f of x is 0? Well, that could be either 0 or negative 5, as we found up here. So we're going to say either negative 5 or 0. All right, we're going to find the value of each expression given the graph. So for 1, f of 4, so we got 1, 2, 3, 4. 1, 2, 3, that value is going to be 3. F of negative 2, well, here's negative 2 here. And so we go 1, 2, and that's going to be 2. For these two, we've got g of negative 1. So we go back to negative 1, and we follow it down, and that's going to be negative 2 for your y value. And at g is negative 3, g of negative 3, 1, 2, 3, 1, 2, 3, 4, negative 4 is our y value. All right. So this one is a discrete graph, and this one is a continuous graph. Now let's talk about the domain and range. The domain of this one, well, we've got negative 2, negative 1, 1, 3, and 4. The range is going to be negative 1, 0, 2, and 3. Now for a continuous function, our domain here is going to be 1, 2, 3, 4, 5, negative 5, 2, infinity, because we have an arrow on that side. Our range is going to be negative 4, and because the arrow is also pointed up, infinity on that end. Okay, let's take a look at a couple more examples. We're going to use this graph on the right to find these values. So what is the value of f of x when x is negative 1? So we go to x is negative 1, we follow our graph down, and the value is negative 3. For f of x, when we have 1, we go to x equals 1. F of x is on the y-axis. Our y is 1. And then when x is 1/2, it looks like our y value is 0. For this one, we are going to use this graph to find the values. So when x is 2, our y value is 3. When x is 6, our y value is 1. Now, when our y value is 0, our x value is 5. So that one we do backwards. They tell us what f of x is. We have to find the x value that makes that true. And that's going to be 5 because y is 0 at 5. All right, for the last set of examples, we're going to, given the following functions, evaluate for the given values. So we have an f of x function, a g of x function, and an h of x function. So f of negative 4, we're going to plug in negative 4 for this function. So we got negative 3 times negative 4 plus 6. So that's going to give us 12 plus 6. So that is going to be 18. H of negative 8, that would be this function. We've got 32 over negative 8, and that's going to give us negative 4. G of 3, so that would be our middle function here. We've got negative 3 squared plus 2 times 3 minus 5. Now, be careful here because the negative sign is outside of this 3 here, okay? So we're only squaring the 3, not the negative. So we have negative 9 plus 2 times 3 is 6 minus 5. So negative 9 plus 6 gives us negative 3 minus 5 gives us negative 8. For h of 16, we're doing 32 over 16, which gives us 2. For f of 7, we go back to the first function, negative 3 times 7 plus 6. That gives us negative 21 plus 6. And so we have negative 15. For g of negative 2, we're back to the middle function. So we got negative 2 squared plus 2 times negative 2 minus 5. So we have negative 4. Because we squared the negative 2 squared is 4, and we still have the minus out in front. 2 times negative 2 gives us negative 4 minus 5. So negative 4 minus 4 is negative 8, minus another 5 gives us negative 13. H of 4, we're back to doing 32 over 4, which gives us 8. F of 0, first function again. Negative 3 times 0 plus 6, well, that's just going to give us 6. And then finally, g of 2. We've got negative 2 squared plus 2 times 2 minus 5. So that's going to be negative 4 plus 4 minus 5 which gives us -5, because our -4 and our +4 cancel. So that's how you evaluate functions based on what your x is. All right, that's going to do it for section 4 of the unit. Our final section, section 5, will cover writing functions and then determining if we have a reasonable domain and range.